All right, so using FOIL method here, first terms, 3 times 2 is going to be 6. And then the outside term, 3 times negative 5i, is going to be negative 15i. The inside term, positive 4i times positive 2, to get 8i. And the last term, 4i times negative 5i, leaves us with negative 20i squared. All right, so we want to now replace the I squared with negative 1, and then combine, which these two are going to be the real part of the answer, and these two are going to be the imaginary part of the answer. Okay, so the F and the L are going to be the real parts of the answer, the O and the I part of the FOIL are going to be the imaginary parts. So when we put negative 1 in here for I squared, we got negative 20 times negative 1, so that's going to be plus 20. All right, so let's just write that just to make everything clear. We get plus 20, right? Because negative 20 times negative 1 gives us positive 20. Now we combine that positive 20 with the positive 6 to get our positive 26 real part. We combine the imaginary parts just like we would any other similar variable, similar terms. Negative 15 and positive 8 leave us with negative 7i in the proper form, real part plus or minus imaginary part. So that's our answer. Okay, so this was one example of multiplication, a real number times a complex number, and put it in complex form. Here was a complex number times a complex number. We used our FOIL method. Now another example might be something like this. Let's say 2 minus 3i squared. If you're faced with something like that, that's really no different than what we just did here, except it's written a little bit differently. This is nothing more than 2 minus 3i times itself. So I think it helps to write it out, and now we're right back to where we were before. FOIL method, we get 2 times 2 is 4, we get negative 6i on the outside, negative 6i on the inside, and positive 9i squared on the outside. We got a negative 9 here to combine with the positive 4 to get the real part of our answer, and negative 12i for the imaginary part. All right, so that is 3 different ways you'll see multiplication of complex numbers. Let's see if there's anything different here I should remind you of. Sometimes you'll just have an imaginary part without a real part. Again, if there's no real part, just think of it as a 0, something like this. You say 3i squared. That's, again, nothing really too difficult. That's just 3i times 3i. We multiply that together. We get 9i squared. We don't leave i squared in our answer. We know this is equal to negative 9. If we're asked to put this in standard form, we say negative 9 plus 0i. Okay, so if there's no real part and you're specifically asked to express your answer in standard form of complex numbers, put that 0i in to account for that. All right, and now one more thing in this section of 1.4 is we want to be able to deal with any negative value under a radical. So remember, we started this section with the square root of negative 1. So we're going to see stuff like this. And you're going to have to deal with negative values under square roots. Now we know there's no real number that makes that true, right? No two numbers multiplied together will give you a negative. This is going to involve an imaginary number. So what we do with these is we remember from our properties of radicals, we can factor that negative 9 into negative 1 and positive 9, right? And by properties of radicals that, in this case, hold with the imaginary values, we can rewrite this as square root of negative 1 times the square root of 9. That's a valid step. We've determined earlier in this section that this is the imaginary number I. We know the square root of 9 is 3, so now this just becomes 3i. I times 3, 3 times I is the same thing. Generally, we put the number in front of the I. So that's all we're looking for. If we were asked to put this in standard form, we would say 0 plus 3i. Now, it's not always going to be a nice perfect square like that. 9 happens to be a nice perfect square of 3. Sometimes we'll have values that are not perfect squares. And you'll be asked to deal with things like that. Whenever you see a square root of a negative number in a problem, deal with that first. Change this to this first before you do any multiplication, before you do anything else. When you see square roots of negatives, do this step first, then move on. Okay? So like this, again, we're using the same technique as we used here. We're always going to take this -1 out, but then we want the largest number that's still a perfect square, that's a factor of that number. So we look at 75 and hopefully 25 comes to mind, right? So we can now break this up into -1 times 25 times 3. And by properties of radicals that hold for complex numbers, we can now write this as square root of -1 times square root of 25 times square root of 3. Dots for multiplication, right? So there's nothing we can do to simplify this, but this becomes 5, and this becomes I. So 5 root 3 times I. 5 root 3 times I. Right, so that's how we deal with negative values under square root. So you'll see these. Let's do one more here. Let's do part A of checkpoint 4. On page 141. It's an example of where this shows up. You're asked to add the square root of -27 plus the square root of -48. So again, don't do anything until you change those negative radicals into terms with i's in them. So doing just what we did just before, we're going to break this up. And once you do a few of these, you don't have to show each individual in-between step. You can go straight to here to what it is if you can see it. But in this case, we'll go through the process. -1. 27 is not a perfect square, but 9 is. So we can have this for square root of -27. And then similarly here, 48 looks like, say perfect square 16. 16 would be the largest perfect square. So we'll take 16 out and again be left with that root 3. So this now becomes 3i root 3. Again, it doesn't matter what order you put them in, it's just like 2 times 3 is the same as 3 times 2. Just sometimes you don't want to put the I over here because there's confusion about is it under the square root or not. So it's a good idea to sometimes put the I in front of the square root. I should have done that over there, but that's okay. And then the same thing here, 4i root 3. And now just like similar terms we can combine similar radicals, right? We got 3i root 3's and 4i root 3's, so we can combine those into 7i root 3's. And again, if you're asked to put this in standard form, there's no real part, so you put 0 plus 7i. Okay. All right.